How are we doing today, guys? It is a wonderful, happy Friday here when I'm recording this video. I don't know when you're going to watch it, but, we're going to do some more with some rational functions. We're going to check out our oblique asymptotes. But before I begin, this is a new 2020 collection, packable down vest from the Costco. I'm super psyched about it. Paired with my 2015 Costco flannel. So, rocking the flannel Friday. Got that vest because it was a little chilly out this morning. But let's hop to it without further ado. We're going to be getting into some oblique asymptotes, sometimes called slant asymptotes. We've only dealt with really horizontal asymptotes up to this point, but now we're going to introduce that. Once again, a little refresher. A rational function is of this form where p of x and q of x, those are polynomial functions, okay? And our denominator cannot be 0, right? Wonderful. Moving on. Horizontal asymptotes. If you didn't jot this down in the first video, I would do that now. For same over same, we're going to compare our coefficients. So for this example here, it'd be 1/2, y equals 1/2. If it's small over large, for example, this one here, and it can be really way smaller in the numerator and larger in the denominator. It doesn't just have to be one apart. Oftentimes we do see that, but it could be a drastic difference here. We see a degree of like 3 difference. It's going to be y equals 0. But now we have the large over small, which we said no horizontal asymptotes, which is true, but we have an oblique asymptote or something else. So for the ones that we're going to deal with in this class, we're looking at our oblique asymptotes, larger by 1 degree and then smaller here, okay? So we're just dealing with like x squared over x or x cubed over x squared. The other situations, we would have like a parabolic asymptote, something that's outside the scope of this class. We aren't going to deal with that. But just so you know, that's a situation where we'd have like x to the 4th and x to the 2nd. That's 2 different, right? We only want larger by 1 degree for our oblique asymptotes. So again, pause it here if you need to jot some of that down. If you didn't do that earlier, this is the new part right here with oblique. That's what we're going to deal with today. Alrighty, so our oblique asymptotes, let's formally write some things down here. When the numerator of a rational function has a degree exactly 1 larger than the degree of the denominator, then we have an oblique asymptote, right? Or a slant asymptote. It's another name for it. Okay, so a function cannot have a horizontal asymptote and a slant asymptote or oblique asymptote. It's going to have one or the other, right? So the function values will approach negative infinity or positive infinity following that line as it approaches negative infinity or positive infinity. Lovely. That sounds fantastic. So the equation of this asymptote is actually the equation of a line, y equals mx plus b, but our slope is not going to equal 0, right? Because if it was 0, then it's just horizontal, and we're back to horizontal asymptotes. So we're going to have some kind of a slope there. Now, to find this oblique asymptote, we're going to be using either synthetic division or we're going to be using long division, right? But in general, we're going to be dividing. We're going to ignore the remainder, and then that's going to give us our equation of the asymptote. All righty? So if d of x, our denominator, right? So if we're looking at this form right here where we're dividing numerator as a function of x over the denominator, if d of x is of the form x minus c, like a binomial, a linear binomial, then you can use synthetic division. Otherwise, we have to use long division. All right, so in this one that was up here, we could have used synthetic division. We're going to do an example of each, and then you're going to try a couple of each on your own, and then we're going to graph one big one together. Sound good? That sounds fantastic. I'm excited about it. I think we've done enough talking in words and things and stuff like that. Let's get some problems in the mix. All right, so here it says find the slant asymptote, otherwise known as an oblique asymptote, but who can spell oblique, right? No, we should know how to spell oblique. It's not pronounced oblique, okay? It's oblique. Excellent. So here I have a denominator of the form x minus c, right? So that means here that I can use synthetic division. Excellent. I can avoid long division. I have a feeling long division will be coming though. So I will do some synthetic division. Let me grab a color here. Let's see. What do we want to go with today? I'm thinking, I'm drawn to this blue color here. So I'm going to throw a positive 1 in the box, right? I got that from my denominator. Solve that, set equal to 0 and solve. And then I'm going to go ahead and write my numerator in. We got negative 3. I'm missing a linear term, so I do need to throw a 0. And then I've got my constant. Excellent. Drop down that negative 3. 1 times negative 3 is negative 3. Add them. 1 times negative 3 is negative 3. And I don't really care about that remainder. All I'm focused on is this is my constant, and this is my linear term. So I have the formula, it's not the formula, the equation, negative 3x minus 3. That is the equation of my slant asymptote, my oblique asymptote. And I think it would be helpful to take a look at this on the graph and see, like, what does this actually look like right here, okay? Wonderful. I'm going to pull up some Desmos to do that. All right, so here I have my Desmos graph. I've already typed it in and adjusted the window accordingly so I can see what's going on. So I've just got my function here, but I don't have any asymptotes in there. Well, first off, we could do our vertical asymptote, which is x equals 1. I think we could do that. All right, and why don't I change that? I'm going to change that to a dashed line. Look at this. Look at this. Boom. I like it. There's my vertical asymptote. And then the one that I just found, I'm going to add another equation in there. All right, and that was negative 3x minus 3, right? Negative 3x minus 3. And why don't I go ahead and dash that bad boy as well? Oops. Sorry about that, guys. As I was trying to dash the line, the toolbar would come up for the video recording software. But now I've got it, all right? I just paused it and dragged it. You know, problem solving on the fly. So there we go. I've got my two asymptotes in there. My oblique is green. Look at that. You can see that the graph, as we approach negative infinity for my x values, I am approaching positive infinity for my y's. And as I approach positive infinity for my x values, I'm approaching negative infinity for my y values. So we can talk a little bit about end behavior there as well. But that, as you can see, it just gets infinitely closer. Much like a horizontal asymptote, as we've seen, it can cross and come back. But really, this is just talking about what that graph is doing. It's getting infinitely closer to this line, never going right on it. It can cross and come back, but it's just approaching it infinitely closer. Wonderful. There's our first one. Not too bad, right? All right, we're going to hop back some notes. We're going to do one. I have a feeling it's going to involve long division. I know it is because we wrote them. All right, new problem here. We've got to find the slant asymptote or the oblique asymptote once again. Now, this one we can see that we have a quadratic in the denominator here, right? This is not of the form x minus c. This is ax squared plus bx plus c. We cannot use synthetic division with this one. We're not going to. There are some fancy methods, I believe, where you can do that. Never something that I'm gonna. I don't have any interest. I'm gonna go with my long division. We can handle this, okay? So when I set this up, I'm gonna have x squared plus x plus 1, and then inside we're gonna have 2x cubed plus 3x squared. I am missing my linear term, so plus 0x plus 2. Now the nice thing about these problems, or I guess, you know, it is kind of a pain, but we get to stop early. We don't have to fully long divide. You'll see why here in a sec. So I want to know 2x cubed divided by x squared. What does that give me? That gives me, and I'll use a different color here. We'll go with darker blue. That gives me 2x. You can think about that in one of two ways. X squared times what gives me this, or this divided by this gives me what? Okay, so the 2x, I'm going to get that regardless. So 2x times x squared gives me 2x cubed. Those should always match up. Otherwise, you did something wrong. And then I just multiply to the x, and I get 2x. And then I multiply to the 1, and I get, 2x squared. And then I get 2x. Now I'm going to draw my line, and I'm going to subtract. So I got a nice little rhyme. You ready? Draw a line, change the sign. Make them all, boom, subtraction, subtraction, subtraction. That's going to cancel. I'm going to be left with x squared and then negative 2x. And then I'm going to drop down that 2. And now I'm going to do it all over again. Except for now I'm focusing with this and this guy right here. So x squared, I'm going to get 1, right? 1 times x squared gives me x squared, or x squared divided by x squared gives me 1. Either way you like to think about it is cool. And now I'm going to multiply through. And, well, really, I don't even need to do that. I have y equals 2x plus 1. I am done. That is my oblique asymptote. I'm ready to rock and roll on this graph. So let's, once again, pop up some Desmos and take a look at this, see if it looks right. I always like to look at the graph as well just to make sure we did everything correctly. So here we have Desmos. I already popped everything in there so we don't have to type it in ourselves, save a little time. And this one's definitely pretty funky. Like, there's no vertical asymptote here. We don't see anything approaching positive or negative infinity. And the reason why is if you look at this denominator, there's nothing that's going to ever make it 0, no matter what I plug in for x. If you were to plug this quadratic into the quadratic formula, you'd end up getting a -3 under the radical, which would give you imaginary numbers, so we're not going to have vertical asymptotes. You can have these types of problems without vertical asymptotes. We don't really graph them by hand or anything like that, but it can happen. It's not like it's not able to happen. But as we can see here, as I approach negative infinity for my x's, I'm going to negative infinity for my y's. Just getting infinitely closer. It does cross over the oblique, as we talked, that can happen. And then it comes right back to it, right? It's like, hey, man, I'm just going to cross, oh, but I miss you, you know? And then it's coming right back to it. So as we go to positive infinity for my x's, my y's are also increasing and going to positive infinity as well. All right, there we go. 2 different examples, one where we used synthetic, one where we used long division. I think now it's time for a couple you try it problems where you'll pause the video, try the problem, and then you can hit play and you will see a fully worked out solution. So let's hop to that. All right, so here's the first problem. We want to find the oblique asymptote. Again, oblique, slant, you know, whatevs. Just be familiar with both just in case it's worded one way or another on a test. You now know how to spell oblique in case you didn't write down earlier. So what kind of division are we going to have to use here? What kind of division are we going to have to use? I don't have an x minus c form down here. I don't have a linear binomial, so I'm going to have to go with long division. How about we set up the long division? If you think you're good to go for it, and pause the video right now. But if you want to see how we set up the long division, just to make sure you have that right before you start going, I'm going to do that right now. All right, so we're going to have negative 2x squared plus 0x plus 18. Then we have 6x cubed plus 0x squared plus 0x minus 1. This is not an easy problem, but I've got confidence. You guys can handle this, all right? So now pause it, and then we're going to throw in the real solution after you unpause the video, all right? Did you pause it? All righty, so we got it. It's all lovely and nicely typed up. Sorry, it's a little blurry, but I'll zoom in a bit on it. Let's see if I can do that. There we go. So we did our long division. You should have gotten y equals negative 3x. As you see, they have some spaces there instead of putting in the 0x. You know what? I'm going to pause it, and I'm going to write this out, write out the long division showing those missing terms, because I feel like this is a little bit, you might get a little confused. If you made a mistake, then you can check and see where you went wrong. All right, here we go. So I wrote out with those 0 placeholders for each missing term. And as you can see down here, we end up getting a 0x squared, which is why we're going to have no constant term here. And we just have the negative 3x, which is what we have here. And then a look at your graph. Boom, there it is. I know it's not as pretty as Desmos, but you can still see we have that negative 3x. The scaling is a little different, so it does look a little bit flat, but that's what that one would look like. You can see it's actually going to cross over the oblique asymptote there. But again, if you got that oblique asymptote, you were able to get y equals negative 3x, you're a rock star, you're doing great. We're going to do another you try it example. So here it is. You try it. All right. What can we use on this one, though? It's a linear binomial down in the denominator. I can use synthetic division. That's awesome. Go for it. Pause the video, and then we'll see a fully worked out solution when you guys get back. All righty, here it is. We got it all nice and typed up. So again, we got -1 in the box. Work out some synthetic division. We get a remainder of -4. We don't really care about that, right? All we care about is this portion of it. There is my oblique asymptote, and then we've got ourselves a nice little look at the graph there, right? Our oblique asymptote would be coming through something like that. Actually be coming through at the -1, so be below, something like that. I like it. Wonderful, fantastic. That's good stuff. Even got our vertical asymptote at x equals -1. We dash those, but this image is a solid line, so normally we would be dashing those guys. Awesome. I think it's time for a full-on beast of a problem. This bad boy down here. Woo-hoo-hoo-hoo. Example 3. All right. We did 2 examples as a class. You did 2 on your own. Those were the you trieds. Now we're back. Final example, the final level. Let's do this thing. Shall we? I think we shall. So we want to factor that numerator and denominator. I'm going to get that into factored form, and I'm liking this color right now, so I'm going to go with it. Let's see here. What multiplies to 2 and adds to 3? That'd be x plus 2, x plus 1. This is weird. We're not factoring our denominator, only our numerator. Well, our degree is larger in the numerator, isn't it? We're going to have ourselves a little slant asymptote or oblique, whatever you prefer. So my domain. Well, my domain is all about the denominator. I don't want x to equal 2. So x such that x does not equal positive 2, because that would make the denominator 0. Let's see here. Vertical asymptotes. I'm going to jump down to vertical asymptotes. I like looking at that one next. Well, nothing canceled here, so I don't have any holes. And what's left there are my vertical asymptotes, right? I look at those kind of together, the vertical asymptotes and the holes. So I'm going to have x equals 2. There's my vertical asymptote. Let's see here. Now it's time for some horizontal or oblique. We got the x-intercepts and y-intercepts. I'm eager to do some oblique asymptote action. So I'm going to back out just a little bit here. I'm going to set up some synthetic division because I have that linear binomial in the denominator, denom. So I've got 2 in the box, throw 1, 3, 2. There's no missing terms. This one is just nice and straightforward. Watch, I make a mistake as I'm saying that it's nice and straightforward. That would be hilarious. I hope I don't. Then we got 10 and then 12. Boom. I don't care about the remainder. What I do care about is, this is my constant, that's my x. So my oblique is y equals x plus 5. Nice. Good stuff. Fantastic stuff. Excellent. All righty. So x-intercepts and y-intercepts. Well, if I set my numerator equal to 0, meaning my y value, my function value is 0, then I can find the x values that would be crossing right at on my x-axis, because anywhere along my x-axis, that's where I'm getting a y value of 0. So let's set our numerator equal to 0. I'll do that up here because I've got some space. I've got x plus 2 equals 0 and x plus 1 equals 0. So I'm going to get x equals negative 2 and x equals negative 1. Those are going to be my x-intercepts. So negative 2 comma 0 and negative 1 comma 0. Nice. Now for my y-intercept, that's when my x's equal 0, right? If I'm along my y-axis, all my x values are 0. Everything's 0 comma something along here. So if I plug 0 in for x, I know everything's going to go away except for these two terms. So it's 2 divided by negative 2, which is negative 1. So we get 0 comma negative 1. All right. Now for my for the rest of this here, I'm going to go ahead and wait until we graph it to talk about our end behaviors and things. All right. So let's go ahead and start plotting some stuff, shall we? I'm going to stick with this color. I'm really feeling this color right now. It's nice and vibrant, really waking me up here on this chilly Friday morning when I'm recording this video. Who knows when you're watching it? Perhaps it is today. Perhaps you're watching this on a Monday. I don't know. But I hope you're enjoying it as much as I am. So let's see here. I'm going to scale this out, and I'm going to use actually a different color for scaling. I'll go with the color of the graph. I'll pause it. All right, so we got it all scaled here. We got 8, 8, 8, 8. Cool. I'm going to throw in my vertical asymptote. I'm going to use this fancy ruler. Let's see how this goes. I have a vertical asymptote of x equals 2. Got it to 90. Nice. That's vertical right there. Woo! Look at that. Okay, and then my oblique asymptote is x plus 5. Y equals x plus 5. So that means I'm a slope of 1, which would, for those of you having fun here, that's a 45-degree angle. So I got 1, 2, 3, 4, 5. And if I scaled this nicely, it would have gone through the other one there. So I'm just going to adjust this because my scaling wasn't perfect. Bummer. That would have been cool. I'll go to there. So my oblique is that one. All righty. Get rid of that ruler. Now, let's see here. We've got some missing, we're going to see more of one part of the graph than the other, but that's all right. So my intercepts, and you know what, I'm going to change colors now for the graph, and so that way we can see it a little bit better, you know, with the asymptotes going in one color. So I've got my x-intercepts of negative 2, 0, and negative 1, 0, right there and there. I've got a y-intercept of 0, negative 1, which is right here. So this graph is going to be looking something like this. I know it's going to be in this section. I'm actually going to have it pop up a little bit more. Whoa. These are always a little tricky on this tablet. The screen is a bit slippery. That looks kind of... It's all right. I'm sorry, guys. So it's a little bit tough. But I'm going to give it one more go, but I'm going to pause it. Okay, I like that a little better. Less all over the place. Now, the other portion of this graph here, where's it going to be? We got to figure that out. You know what I'm going to do? I'm going to just test. I know it's going to be on the other side of this vertical asymptote. What if I test like the value of 1, 2, 3 into my function? If I plugged 3 in, so if I did P of 3, what would I get? If I plug 3 in, I'm going to get 5 times 4, which is 20, over 1. So I'm going to get a value of 20. That means it's going to be somewhere up in this section up here, right? So I'm going to end up having a kind of a mirror image of a graph that looks like that. And we can't see all of it, but that is what's going on. And maybe I'll add in the, extend that vertical asymptote a little bit more. There we go. So again, it's going to do the same kind of thing, just in that other section, right? They're going to be on opposite ends. Now, if we had something else going for like our vertical asymptote here, if that was x minus 2 binomial quantity squared, then we would see something a little bit different. But we'll deal with that when we get there. So for now, we've got to get our end behaviors. Okay, so as x approaches infinity, so as x approaches infinity, meaning as we're going further and further to the right, what's the y doing? Well, it's going up, right? So that means that x is approaching positive infinity as well. And as x approaches negative infinity, what's going on with the graph? Well, it's going down. So it's going to negative infinity. Nice. And we can even talk about our asymptotes as well. It doesn't ask us in this one, but as it approaches, I'm going to do it. I'm going to do it because I'm just having so much fun here. As x approaches positive 2 from the left, f of x, or y, approaches, as it comes in from the left side, it's approaching negative infinity. And then as x approaches 2 from the right, then f of x is approaching, well, as it comes in from the right, it's going up. So it's going to positive infinity. I love it. That was so much fun. That was fantastic. It's a beast of a problem. Oblique asymptote. Man, we had some stuff going. We had 3 points we were able to plot too. That was pretty exciting, I'll tell you what. It's always nice when you got a few points to base everything off of. Hope you guys enjoyed it and enjoyed this video here. So you guys have a fantastic day. You enjoy the weather, and we'll see you guys in class. Adios. America Freedom, rock and roll, Costco, America Water Stain. All right.